So welcome to the CIA webinar on CAN in agriculture, forestry and heavy-duty commercial vehicles. Yes, to start is I want to say some words about the objective. We want to inform you about ongoing and existing standards, specifications and challenges. In addition, I'm open for any kind of question. You can use the chat, or then I will answer the questions after the presentation, or you can interrupt me whenever it is time and you don't understand. Then please use your microphone and have the questions and I will answer them. Just a few words to my person. I'm Holger Zeltwanger. I'm an electronic engineer and a technical journalist for more than 40 years. I initiated the foundation of the CIA user organization, and I'm a member of the CIA board of directors since the establishment. I'm also convener in different ISO working groups for in-vehicle networking and network applications. I'm also expert in other ISO working groups, in IEC groups, and I'm also an expert editor and convener in DIN working groups and committees. Most of them have some relation to the topics which we discussed today. I'm also a member of the SIE J939 committee and several task forces, and also for J2284, which is the CAN task force, and for the J2602, this is the LIN task force. So you see, I have sometimes different hats on my head. So I have to answer this sometimes from different perspectives, whatever I'm representing. In the moment, I'm using the CIA hat mainly. You see, I'm quite old, and I have been from the beginning involved into the CAN technology. So this is the original press release from 1986. When Bosch and Intel together announced the availability of the CAN protocol. And this is a long time ago, 36 years. And the official date of birth is the February of 25th in 1986. Still a little history. In 1992, the CIA organization was founded. This is 30 years ago, so we celebrate this year our 30th anniversary. And in those days, this was the year also when the first smartphone, or no, the first modular circular phone was introduced in Germany. So the first call was then close before Christmas. And in this year, we have from the CIA 15 members, so this was a quite young organization, demonstrated on a fair CAN physical layer interoperability, because in those days there was no connector pinning specified, there was no physical layer, no transceiver standardized. Anything was proprietary, and we tried from the beginning to provide interoperable products from different vendors. Also, we have since 30 years the CAN newsletter. You see the very old version, the very first version from June 1992. This was still not really a magazine. It was still handwritten more or less and copied and then distributed to about 500 subscribers. Before we go into the details of what is available today and what has been developed and why it has been developed, just a brief history on the development of higher layer protocols. CIA started in 1992 the development of the CAN application layer, which was a very academic approach. And it was, of course, it was used in some applications, but this was too resource requiring specification, and so it has not that big commercial success. This is why in other associations like the SIE, there was developed the J9039 and published for the first time in 1994. CIA took over from a European research project, something what was related to the CAN application layer, but it was just a profile which you can implement more easily and without or with less resources. In 1998, there was another J9039 based network with two partners, a truck and a trailer, and they were linked in the ISO 11992, the 2 series. We come to that in more detail. CIA published then 3 years later the first CIA 413 series of truck gateway profiles connecting J9039 networks and CleANopen networks. In 2001, the same year, ISO published the 16804 series, which is a J9039 based tachograph. Also, this will be reported a little bit more in detail. 3 years later, CIA released the CIA 422 series, which is the CleANopen profile for refuse trucks. Here you see the first time that we are using that what we like to call a machine on wheels. This is a complex network system which is used for refuse collecting trucks. In the same year, also the marine industry took over J9039 and specified a navigation network using the application layer from the SAE. FireCan was introduced in 2006. It was a CleANopen based profile for firefighting equipment mounted on trucks. And last but not least, we have that what is for the agriculture and forestry machine. In 2007, there was introduced the ISO 11783 series, which is today known also as Isobus. It is also based on J9039. Some of the specifications have been in the meantime standardized. So FireCan is standardized in DIN 14700, and the CIA 422 series is specified in the European standard 16815 from 2019, and the marine network is also an ISD standard now. So this just to give you an overview what we're talking today about, except maybe the marine navigation network. Let's have a closer look to J9039 documents and how this is represented in the open system interconnection model. So you know the 7 layers, and you maybe are familiar with that, starting with the physical layer, the data link layer, the network layer, the transport layer, session, presentation, and application layer. To be honest, those standards which we have seen before, they only partly can be mapped to this model. But nevertheless, we should try to do that, because otherwise young people and those people reading all the thousands pages of specification will be confused. You see here a first idea, what is in the different documents represented. You see for the physical layer, it's quite easy. We have different options. We have twisted shielded pair with 250 kilobit. We have untwisted unshielded pair. Okay, there's a typo of 250 kilobits per second, and we have in J9039-14 a 500 kilobit option. In addition, and this is quite new, there's also a possibility to use CleANFD for J9039 networks, and then you have the -17 standard there. This specifies a 500 kilobit arbitration bitrate and a 2 megabit data phase bitrate, so that you can accelerate in the second part of the frame the speed. The data link, what is called data link layer, normally this is already specified in ISO 11898-1 from the CAN protocol point of view. But there are some additional requirements in J9039 how to use the data link layer. And this is specified in J9039-21. And this also includes a network layer, how you assign the addresses, the source address and the destination address. There's also a transport layer, and we will come to that a little bit more in detail for both for CleANFD as well as for classical CAN. Most important for J9039 is, of course, the application layer, and that what is called, what is outside. This means the content of the data, all the parameters and the parameter groups. They are specified in the digital annex, and we will come to that in some detail and look how this fits to our requirements for all the others, and where you find the appropriate specifications. Just a hint. In J9039 documents, the terminology is not used consistently. I'll give you just an example. One example is the term PGN. Normally, all development engineers use PGN as a synonym of the parameter group. But to be honest, the PGN is just a number. Of course, it is a unique number, so to say, an identifier for the parameter group, and this is assigned uniquely by SAE. This is not a PGN. We have started in SAE to change all the document because this was used throughout all documents and was confusing people. We have the same issue with the SPN. The SPN is the suspect parameter number. This is also a unique number identifying the suspect parameter. But if we talk about the temperature, oil temperature, or whatever it is, this is not the SPN. It is the suspect parameter. So if you read the documents, sometimes there's still the old terminology used, and there are thousands of pages which we have to update, and this will be not done in one shot. This needs some time. So to summarize, the parameter group, and this is true for all J939 documents, is a message, so to say, an entity of the application layer, identified clearly by the parameter group number, the PGN. The PG is either not a frame, even if some people would name it in that way, it is because the frame is an entity of the data link layer, nor a segment. This would be an entity of the transport layer. The SP specification and the SP mapping into PGs are not in the scope of the 7-layer OSI model. This is done in so-called the data layers by means of profile specification. So if we have this in mind, then we will not be more confused when we read several of these documents, because this is not consistently described. I think most of you are quite familiar with J9039-21. However, for a couple of years ago, we started to specify the mapping to CleANFD frames. You know, CleANFD frames have a longer payload, so they have a maximum payload of up to 64 bytes, so that we can map several of the existing parameter groups into one frame, one CleANFD frame. We can use the 11-bit identifier or the 29-bit identifier. CIA recommends to use only the 11-bit identifier to minimize the overhead, because the identifier is transmitted in with the arbitration speed, which is, in this case, when we're using J9039-17, just 500 kilobit per second. The remaining part, the CleANFD data field, this is transmitted with a higher speed, with 2 megabit per second. So that means at the end, we can transmit several, what we like to call contained PDUs. These are the normal parameter groups, could be also different ones. In these parameter groups, we can use the same 8 bytes, the same mapping as in the past. However, we can transmit in one frame multiple of them. This also makes system design much easier, because now you have you have not to harmonize and to synchronize different parameter groups. You can map them into one frame and transmit them together on the bus. Let's have a look to the multi-PDU a little bit more in detail. If we map this to the base frame format for FD. So we have the 11-bit identifier, and the 11-bit identifier contains only the protocol indicator. And we have written there 0. This indicates I'm using the multi-PDU protocol. And I map into the C-PDUs always one parameter group. So at the end, if I'm using for all C-PDUs, legacy ones, the parameter group with 8 bytes, then I'm limited to about 5 CPUs into one data frame for a CleANFD. Of course, if I would shorten the parameter groups in the future, then I can map more into one of these multi-PDUs. Let's have a look to the contained PDU. The contained PDU, and this is intended to be used also with AUTOSAR to be compliant with AUTOSAR. You see that we have selected the PDU short header, which is 4 byte, and the 4 byte. This is just we can have also a long header, but in this case we are using the short header of 4 byte, and then follows the payload. This is up to 60 byte. If we would use of variable length, the parameter groups. But today, the parameter groups are all, except the one, using the length of 8 bytes. In addition, this contained PDU may provide a safety security trailer of 0, 4, or 8 byte. So it's already intended that we can add for each of these contained PDU some safety information or some security information. In the short header, which is an overhead, of course, there we have first of all the type of service. Type of service is in this case coded as 001, and we have then the 3-bit length. This indicates the length of the trailer. How long is the safety or security trailer? As I said, in the moment we have specified 3 values, 0, 4, or 8. Then we have the 2 bits, which you know from the parameter group number in J9039, the data page. We have the protocol data unit and the specific information. Together, this is the parameter group number, and then we also need an additional byte to indicate the length of the following payload. Today, when you're using the legacy parameter groups, this will always be 8 bytes. But in the future, it could be different. J9039-22 also specifies 2 transport layer protocols, the so-called CleANFD BAM, Broadcast Announced Message Transport Protocol, which is of course optional, because if you don't need it, then you don't have to implement that. And the maximum data length is 15,300 byte. The number of concurrent sessions is 4 per source address. The minimum support is 1 per source address. Safety and security is possible. And we have an end of message status segment telling this is now the message has been excuse me, coming to an end. In addition, there's a CleANFD request to send and clear to send trans protocol, which provides a very long data length of several million of bytes. Number of concurrent sessions is 8 per relation. Minimum support is 1 per relation. Safety security, we have the same capability as with the BAM protocol, and we have also the end of the message status. So you know this all from some things, but we have now more resources available, in particular the number of sessions as well as the length of data which we can segment. So there is no limitation anymore, so to say. As I said, J9039-22 reserves the trailer for functional safety, respectively cybersecurity. This allows an end-to-end C-PDU protection. If used as a black channel approach, it should be guaranteed that the application layer is, so to say, transparent. This means this is has no issue. Currently, the SAE committee discusses the requirements on that, because how we need, what kind of protection we would need for functional safe C-PDUs. We think about CRC, a running number, and freshness value, and so on. Next week, we will decide in the SAE J939 to establish a task force that would specify the details. And then this will be an additional J939 document describing the measures as well as that what you have to implement if you want to protect your C-PDU. Today, there is just an empty container, and we will fill the container in the next month. And maybe it will take 1 or 2 years to have a stable standard available. And we need also to go to the different authorities in Germany, TÜV, to get approval for those functional safe networking applications. This will be adapted, of course, I think, from different industry, the construction machine industry, as well as the agriculture machine industry. They have their own solutions, but not for J939-22. Just a small background on the ISO 11783 series, which is the Isobus at the end. This is the commercial name for that. You see that we have in the moment 14 different parts published. Some of them are under revision. To be honest, all of them are in a not optimized status. So some of them use old terminology, some are very vague, some have not a well description. So we try to improve all these documents step by step. And yeah, this is a huge task to bring them all in harmony so that a reader can easily understand the documents. Most important is the virtual terminal, of course, because the virtual terminal is one of the famous ideas of the Isobus, so that different implements can share the same hardware, the same terminal, and so that you don't have to provide for each of the attached machines an additional terminal. So the farmer then has just one terminal and can observe all the different attached implements. Just a word to the data dictionary. The data dictionary is much better than the J939 digital annex, because here they have done a good job to describe very well the different parameters, suspect parameters, much more in the style of CleANopen, so that you can easily understand this and easily implement that without any interoperability issues. Interoperability is still a huge issue if it comes to different versions, because if there are different versions implemented from the Isobus which do not fit together, then the farmer has a problem that he has to know which version is implemented in the tractor and which version is implemented in the implement. But there's a database provided so that you can easily see which devices can interoperate with which other devices. So normally we have the tractor with an attached implement. We have then in the tractors the traditional J939 network for the engine, and we have a tractor ECU, and maybe we have a GPS system. In addition, we have in the implement, if this implement is more complex, also a network with different implement ECUs, and we have an implement ECU with bridge functionality to the Isobus. And the interconnection between the two embedded networks in the machines or in the coming from different vendors, there we are using the Isobus, and the Isobus is an open network which provides a good capability to connect implements and tractors and the virtual terminal. And for example, also a gateway to the farm management, if you have a larger farm and you have a fleet management for that. So this is quite well established. It took a while until all the different providers of those implements and tractors have implemented this. As I said, there are some version problems because when they are not backwards compatible, but this is also solved by means of the database. And for new features, there's always organized a big Plugfest with several hundred participants, proving that their products fit together. Because if this is an open system and you are on the field, you can't make any diagnostic or such like things. The farmer is not an electronic expert normally. It just needs to plug these things together and they should work. A similar approach is the connection between truck and trailer for road vehicles. So this was published before, and this was limited to 2 participants in this cane-based link. This is the towing vehicle and the towed vehicle, and so you have just 2 nodes. The physical layer is a little bit different, and they have their own physical layer specified. And there are no integrated IC transceivers on the market openly available. This is one of the problems. ZF, formerly WAPCO, offers its integrated transceiver bilaterally to selected partners. So if you have an interest in to purchase this kind of transceiver, which is different, has another signal value on the bus lines, then you should ask this company or coming to CIA, and we bring you, connect you to them so that you can maybe buy these integrated circuits directly from ZF. Part 2, and we have 2 parts: the application layer for brakes and running gear. And the revision started in October 2017, so we are still in progress with that. We add things, and I will tell you what we are adding. We have also part 3, which is application layer other than for brakes and running gear. This was published in 2021 and is already available. For the diagnostic communication, which is also done via this cane interface, there's a revision started in October 2071, and we are still working on this. There is some information necessary to understand all this. The ISO standard doesn't say how to implement that. So they are completely free. There's nothing mandatory. There's nothing specified what you need to implement. However, the European Union has a regulation that you have to implement part 2 on your tractor and connect this on your truck and connect this to the trailer or the second trailer. If you're the second trailer, then the first trailer is the towing vehicle, and the second trailer is the towed vehicle. This is reserved for brakes and running gear applications. If you want to implement something different for safety reason, you need to have a second CAN line where you implement then part 3. For example, there are some trucks controlling the lighting via this CAN interface, and then you should use 2 CAN lines between the truck and the trailer or the semi-trailer. The application layer is completely based on what is described in J939-21. The data profile uses selected suspect parameters from the J939 digital annex. And there are specific suspect parameter only specified in the ISO documents. all the suspect parameters mapped to a parameter group can be indicated as not available. So this means you would be compliant to the ISO 11992 standard if you implement nothing, just the parameter groups. And in all the parameter groups, you say this parameter is not available. This is still compliant to the standard. So the term or the statement that you're compliant to ISO 11992 or -3 doesn't say anything. Therefore, we need the regulations in the world to regulate what parameters you have to support and which are optional. Also, the parameter groups, they are listed, all of them, in the J9039 digital annex, but the details are given only in the ISO documents. We try to avoid double specification. In the past, they were also the information given in the digital annex, but then the ISO documents were changed and the digital annex was not changed. So you have two different specifications for the same parameter group, and this caused a lot of problems. One of the problems was regarding the, and this is still an issue, was regarding the time and date parameter group. By accident, somebody has swapped day and month, because you know that American people have a different order of this than the European ones. And so it happens that some implementers have first the month and second the day, and other implementers have first the day and then the month. So that means they are only correct at 12 days per year, at the 1st of January, the 2nd of February, 3rd of March, and so on. So you have to be very careful with this. If you see in implementation, then you have to look what they have really implemented. For the document which is in the moment under review, there are additional parameters specified. One of the parameters is in the parameter group EBS 11 and EBS 21. This is for eDrive applications. We have new parameters necessary, and they will be then released with the next edition. We also have enhanced the parking brake status suspect parameter. There's also an enhancement in the electronic in the EBS 12 parameter group for neutral gear status. We have some copies from parameters into the GPM 22 and so on. You see it here, and enhanced and the regulation for European regulation number 13. They require different parameters. For example, the fifth wheel load, ambient air temperature, and this will be also provided then in the appropriate parameter groups. There will be also new parameter groups with trailer software update parameters, so that we know when the software has been updated to prove interoperability between the towed and the towing vehicle. Tire pressure monitoring is another parameter which needs to be included into the EBS 23 parameter group, because this is required by some legislations. And there may be more, because this document is still under review. A brief overview on that, what is available for those which using in commercial vehicles tachographs. This is of course an own standard. Also in Europe, this is regulated from the European government. Also any truck needs to have this, and maybe also other may make use of this to have a fleet control system and appropriate data. Two of these interfaces, the data interface, and this is number 4 and number 5, and the service interface, they are using CAN communication, or the others using proprietary and other networks standardized in also in the ISO 16844 series. So you see here the interface number 4. This is the CAN-based data interface, including parameter groups standardized in ISO 16844-4, and they make sometimes references to the digital annex of J9039 and sometimes not. There's also number 5, another CAN-based, J93-based interface for the service, and this is standardized in this. The data identifier, so this means how you access the for diagnostic purposes the interface. This is standardized in part 7, and there you find a lot of references to other documents and to J939 digital analytics, of course. Just for those which are interested in that, you see that we try to avoid also here a double specification. We just try to use references. Of course, you have there more paper to read. On the other hand, they are consistent, and there's never the problem that you have 2 different specifications. Let's come to that, what is already done for the agriculture machines. We also want to use other body application networks, so to say, implements in the terms of the agriculture industry. So we are specifying a J939 network, which is then giving the chance for bodybuilders to connect their body application units. You see here all that what can be connected. An example is here in EC1, you have the telematic gateway unit, which is quite normal that if you have something to communicate, then you have these, then you want to go into the cloud and store some data. In addition, you have the fleet management unit. There's also a standard for that, the fleet management, for fleet management purposes. And what is needed, you need an in-vehicle gateway to the truck internal networks, which are also J939 based. In the body applications, you can have 1 or 2, depending on the complexity on your body application. And this will be standardized in DIN 4630. This is a German standard. Nevertheless, the standard is published in English language. So we know also in German standardization bodies that we need, even if we prepare something today, we don't want to translate this afterwards. And it is intended to submit this in minimum for European standardization, or even better, for international standardization. In the meantime, you can buy the German standard and use it, implement it, because it's written in English language, so it makes it more easy for you. We have also in the past the problem that we have German standard written in German language, and then we have suppliers from abroad not able to read German. This is a pity, and this we try to overcome in all the commercial vehicles or agriculture industry. No German standard in German language anymore for this kind of applications. So if you don't like this implementation, we are all these functional units which you see here, the BAU, the FMU, and the IGU, and the TGU, they are virtual devices. They are just software entities, and you can move them and you can implement them in other ECUs. So with the same functionality, you can also say, oh, I have my own telematics gateway unit, because I don't want to depend on the truck maker who provide the in-vehicle gateway unit normally together with a telematics gateway unit. I want to separate this. Just use another ECU. You can still combine then the in-vehicle truck gateway unit and the fleet management unit. And because you are the only one who has this more complex application, and you have not 2 suppliers but only 1, then you can say, oh, I can, and your ECU is powerful enough, then you can control both subsystems from the body with 1 ECU. So you have a lot of freedom to implement the DIN 4630 depending on your requirements. Just to show another view, so maybe where you see how this fits all together. You see here a truck and a trailer connected via ISO 11992-2 and ISO 11992-3. Then you have their ECUs, and they provide, so to say, the transparent communication between the two different networks. Could be done locally in the in-trailer network, could be also a J939 one, and the same for the in-vehicle network in the truck. Then you have the gateway, which is number 2, to the body application, and you can have in the truck a body application as well as in the trailer, and they could be different, and they can have their own telematic units, of course, and they may also have their own body applications or multiple of them, but this is depending on your application. Of course, we also need to standardize the wireless communication with the cloud services. That is not yet done. This needs to be done, but this is politically not so easy then to agree on the in-vehicle standards. Which kind of body applications we are covering today? We have the lifting units. This includes vehicle-mounted cranes, according to a European standard. We have the tail lift, which is used by many of the trucks and the trailers. We have heating and refrigerating units. We have refuse collecting units, compliant to a European standard or not compliant to European standard. We have the container unit, removable or non-removable, for liquid tanks or for bulk materials. And last but not least, we have the tipper unit specified, where we have different styles of dump units, rollover container, and so on. Of course, you can also mix them. We see a lot of requirements regarding vehicle-mounted cranes and tipper units. This is quite often used, and they are produced by 2 different companies, and that makes sense to have the open standard where you can now mount this quite easily, because they provide by some means interoperability. A similar application we have with the firefighting trucks. Firefighting trucks are very complex. They have multiple networks. Here you see a simplified figure. You see the in-vehicle networks in the truck. They are connected via SAE J939, the same as with tractor in the agriculture industry. You see the DIN 4630 network, which is it's similar to that what Isobus is. So you connect then the in-vehicle gateway unit and the different body application units. And one of the body application units is already well standardized and specified. This is the CleANopen based network described in DIN 14700. There you have a lot of different firefighting equipment, onboard and offboard units. I will go a little bit no, I will not go into the details. You have light masts, for example, which are external offboard units. You have water pumps, you have water cannons, and you have power devices as well as frequency inverters. All this, there can be multiple instances in that network, and this is already in the moment under development. In the second edition, to harmonize things and to improve this and to provide this also in English language. The same as with DIN 4630, we will have the DIN 4700 network or specification described completely in English. We just have the next meeting in March, and all the manufacturers of equipment for firefighting trucks are invited to support that. Similar approach as this we have for refuse collecting vehicles. This is the official name. Garbage truck is some slang vocabulary, and we use refuse collecting vehicles. You see here the maximum number on virtual devices which we have. We have a body controller, we have bin classification units, container change units, compaction units, food step units up to 8. We have a GPS unit, identification unit, input, generic input-output units, lifter units, measuring units, and we have, of course, the truck gateway unit and washing units. The complexity of such refuse collecting vehicles has astonished me. But you must have in mind, in Switzerland, for example, they have trucks running through the villages with 8 different compartments. So they need 8 different lifting units, and they measure also the garbage for each of the class of garbages, and they wash the units, the bins also. So this becomes more and more complex. In order to provide not just a specification, but also to show that these things are interoperable, CIA has proved this in the year of 2008 already for the first time. And here you see an Iveco truck with the truck gateway from Iveco, and then you have different units from different suppliers. We have had different identification units from competitors. We have measuring units and so on. And we proved that they are interoperable. And this is done quite regularly. For a generic approach for the body application, we have the DIN 4630, and this is maybe not covering all the applications. CIA has a series of gateway interface profiles for CleANopen based body applications like fire CAN, as well as the refuse collecting vehicles or truck mounted cranes from some of the suppliers to J939 based in-vehicle networks. So we provide and specified all ISO 11992 suspect parameters, the same for the part 3 suspect parameters. We have dedicated parameters coming from DIN 4630, as well as the VAK. This is a German non-profit organization for other commercial vehicles, for other vehicle applications like road cleaners and so on. And we have a generic mapping of parameter groups into CleANopen process data objects, as well as we have then possibly for those which have implements in the agriculture industry, so that we can map also the Isobus parameter groups. If this is needed, in the moment there is nothing specified. They all use the part 6, which is the generic mapping. But to make it more specific and more simple, we can also, or we should add something for the agriculture industry. Yeah, coming to the summary and outlook. So as I said, J939 is the dominating in-vehicle network for agriculture, forestry, earth-moving, construction, and mining machinery. In particular for self-propelled machines, we call them also machines on wheels. In commercial heavy-duty vehicles, there's also a strong trend to J939-22, which is CleANFD. But this is mainly for road vehicles, not for the off-road vehicles. They are still a little bit more conservative, and they need maybe some more time to adapt J939-22. As I said, the J939 related documents need to be improved regarding terminology and established editorial rules to improve readability and understandability. Of course, one of the main goals is to avoid misinterpretations, and then at the end, you have different things which are not interoperable. You can overcome this by means of Plugfest, but this is very late in the development process. I would prefer to have this already in when you're starting and reading the documents, so you have to improve the documents. SAE and ISO are committed to improve these documents and to avoid double specifications. This was also in the past not possible. In the meantime, I personally participate in both organizations, and I'm one of the links, and there are several links, so that we can improve the documents also regarding the double specifications which have been done in the past. In-vehicle gateways need to support functional safety and cybersecurity. This is a big issue, and we have no solution for that in the moment, but we need to start to think about that. If you have two different parties, one party has the truck or the tractor, the other one has developed the implement, or the towing, the trailer, or the body application, then you have gateways. At these gateways, we have to support functional safety and cybersecurity, and this should not be a point of attack. This is not so easy to achieve because there is no system designer, and the system designer is the end user. This means the truck driver, or the farmer, or the man at the construction field. I think this is something what we should think about. There are technical solutions possible, but we need to agree on them. CleANopen, this is mainly used as an embedded network in implements and in dedicated body applications, for example, in the refuse collecting of firefighting equipment or other implements, or truck mounted cranes and so on. When it comes to complexity and you want to buy from the shelf, off the shelf, some components or some devices. Okay, this means we are at the end of my presentation. So you can have more information from our website. You can look to our CleAN newsletter and the newsletter magazine. We have also some product guides. And maybe you like to send an email. For the general email account is headquarters@can-ca.org. For technical inquiries, please use service@can-ca.org. If you want to have some education services, then go to events at can-ca.org. For those which like to have their products advertised and want to have some marketing services from CIU's publications. And if you want to submit your press release or other information to be published in our magazines, then use pr@can-ca.org. Then I like to thank you for participating. I hope you got some information which is valuable for you. And as I said, if you want to have more information, there are the different options where you can get this. Thank you for participating, and yeah, have a nice evening, night, or a day, wherever you are in the world. Thank you for coming and joining us. Goodbye.